Okay, hello students. Today let us understand the memory interfacing with 8051. Memory interfacing with 8051. Actually, this is external memory interface. Then what is the internal memory that is associated with 8051? Let us understand that first. Briefly, internal memory of 8051. Actually, 8051 is having 4096, that is 4 kilobytes of RAM. Okay, it is having 4 kilobytes of RAM. That is the first point. (4096) bytes or 4 kilobytes of RAM, ROM, okay, read-only memory. Then what is the RAM size of that is associated with 8051? That is just 128 bytes. Only 128 bytes are there. I hope you know what is bytes means. Bytes means 8 bits. Okay. That's why the structure of our 8051 internal memory is something like this. Actually, this is the ROM which is associated. This is read-only memory. Okay. It is 4 kilobytes. Hence, the starting address can be 0000. Okay. 4 kilobytes means it can be something which is 0FFF. Okay. 0FFF. Hence, it is the only till this the internal memory exists. This is the address mapping of internal memory. Now, what about the RAM memory? What about the RAM memory? The RAM memory which is there associated with 8051 is something like this. This is the internal RAM of 8051. The starting address can be something which is 00H to 7FH, 128. Okay. And 802 255, that is FFH, is having special function registers. These are the address for special function registers, whereas 00 to 7F, that is these 128 bytes whatever are there, no, these are for internal RAM of 8051. If you see this internal memory structure of 8051 is too low. I mean to say it is just 4096 or 4 kilobytes and only 128 bytes of RAM is there. If more program or a larger program is to be associated along with a larger data, in that case it is not possible for us to have the memory which is there with the 8051. We need external memory interface. Need external memory. Why we need? Because only 4 kilobytes of memory is there as well as 128 bytes of RAM is there. If you want more, for example, you want 16 kilobytes of RAM or 64 kilobytes of ROM, read-only memory for program. This is for data. If you want, what you have to do? You have to externally interface that with the existing 8051. That's what we have to do. Now, how to understand the mapping? You see, the 8051 interfacing should be done with a particular lining. That means the address lines. Just to give you the idea of address lines associated, it will be something like this. You know that the address lines that are possible with the 8051, maximum it is 16 lines are there. 16 address lines are available with the 8051. We can use all, but suppose you are using only 10 address lines, what happens is it can map 2 raised to 10, that means around 1 kilobytes of memory. Suppose 11 address lines you are using, that means 2 raised to 11, that is 2 kilobytes. Similarly, 12 address lines if you are using, you are just making 2 raised to 12, that is 4 kilobytes. If you are using 13 lines of the address, 2 raised to 13, that is 8 kilobytes. Similarly, 14 lines if you are using 2 raised to 14, that is 16 kilobytes. Similarly, 15 lines if you are using, that means 2 raised to 15, that is 32 kilobytes. Similarly, 16 lines if you are using 2 raised to 16, that is 64 kilobytes of memory you can interface. That means with the present addressing scheme of 8051, you can maximum interface 64 kilobytes of memory. Lower than that is easily possible. If you want 1 kilobyte possible, 2 kilobyte possible, like this. Hence, this is what is a brief idea of external memory interfacing with 8051. You see, the internal memory structure of 8051 is having 4 kilobytes of ROM and 128 bytes of RAM. Hence, if you want a larger memory or if you want external memory to be interfaced, in that case you should make use of the address lines of the 8051. There are 16 address lines available with the 8051, hence maximum of 64 kilobytes external memory you can interface. In the next slide, I will show you how exactly to interface the memory, external memory with the 8051. Okay, in this session or in this slide, we will understand what are the signals that are used for memory interfacing. Okay, this is very important. I just drawn 8051. Now, first is the address lines. In previous slide, I told you that there are 16 maximum address lines that are available. Which are those? See, this is P00, that means port 0, 0th pin to 7th pin. These are address as well as data lines, AD0 to AD7. What is the meaning of AD0 and AD7? See, AD0 means it is the line, 0th line, which can carry address as well as data. Like that, it is having AD0 to AD7. That means these 8 lines can carry address information as well as data. That means 1 byte of data, 8 bits or 1 byte of data can be carried by these AD0 to AD7. Who decides that? Address latch enable decides whether the information that is present on P00 to 07 is address or data. See, if on ALE, if there is 1, then it indicates that it is address. Whatever information is there, that is address. If ALE carries 0, then it is data. Hence, P00 to 07 or these 8 lines, whatever are there, no, they can act like address as well as data lines. If ALE is 1, then it is address. If ALE is 0, then it is data. Like this multiplexed way, the P00 to 07 acts. Then what about the next 8 address lines? Those next 8 address lines are provided with P20 to P27. These are purely address lines. Hence, these 8 address lines, totally 16 lines maximum will go to where? External memory. Okay, these can go to external memory. Okay, I told you if only 10 lines goes here, it is 1 kilo. If all the 16 lines are used, then it is external memory can be 64, like that. Now, what about PSEN? This is program store enable. This PSEN will go to OE bar of the external memory. Similarly, if you are using random access memory or RAM, in that case, you are using write and read bar. Write and read bar Generally write bar goes to writing. When you want to write some data information into the random access memory, then you should make write bar as 0. Similarly, if you want to read information from the external RAM, then you should make use of read bar. Hence these are for write bar is for writing data into external. Similarly, read bar is for reading information from the external you are using. Then what about EA bar? This is one of the important signal for used. Suppose EA bar is 0, then whatever memory which is there in the internal is not used, but it is used for the external. That means off chip memory. Off chip. The memory which is not there on the chip is used if EA bar is 0. That means if you are grounding this line, then you are using external memory. If EA bar is VCC, if it is VCC, then you are using on chip memory. Like this. See, these are the signals that are used for memory interfacing, but the very important signals are these. Whatever address and data lines, that is AD0 to AD7, and then P20 to 27, which is purely address, and then program store enable, write bar, read bar, address latch enable, address latch enable. Okay, these signals we are using to interface the external memory. In the next slide, let us understand how exactly to interface the external memory. Okay, these two slides, whatever I discussed, are very important so as to understand the interfacing with the external memory. Okay, let us go to the next slide with a problem taken.